Hello everyone, my name is Praveen Deshpande. I come from Big Data Cloud product management team. In this session, we are going to be talking about Oracle Big Data Cloud. Agenda for today, I will give you an overview of why we built Big Data Cloud, what are the key capabilities that we built, how can you bring in data to Oracle Cloud, what are the differentiators, what key use cases that we have, and then finally a quick demo on Big Data Cloud and analytics. So traditionally, if you look at how enterprises store data or how did they get insight into data is largely through relational sources. But today the data is exploding. You have a variety, various styles of data. You have an enterprise applications data, or you have public data that is social feeds, Twitters, Facebooks, or your blogs, etc. There are sensor generated data, IoT, weblogs, user interactive data. So all that data it's a heterogeneous type of data, not anymore just relational, right? So customers are building new data lakes to store all of this data to get more insight into it. Now it is also necessary to get insight into all this data, but you need to work with all these different types of data. So having been in this data management business for almost 40 years, so the vision that we are looking at for big data analytics is that any person that wants to get insight or access to data, he should be able to get access to any type of data that is coming from any type of data source. And simply by accessing a mobile phone or by a browser, he should be able to get some analytics out of it. Now, so let's take a step back, how big data was evolved. Right? So if you look at 2004, 2005, when Google first wrote a paper on big table, so they wanted to solve a problem of distributed computing for storage and compute, and that's how the Hadoop was evolved, right? So but it was a monolithic construct. So what it means is, so you had a data that is stored in HDFS as a data lake, and there are surrounding ecosystem like Yarn, which was for compute resource management, and there is a service discovery manager, right? So then you have workloads that generate logs or results, then you have binaries. So all of that was tightly coupled and integrated and kept within the cluster, big data cluster. Now if you have to scale out on your premises, you will have to replicate the entire cluster altogether. Now when the cloud came into business, or when cloud came into as an innovation, so these constructs did not work well in the cloud economics, right? So what we did was we took a cloud native approach and built all together a different architecture. And also if you look at any of our customers' cloud bills from AWS or Microsoft for that matter, 80% of the cost comes from compute alone, and then the 20% is all about the long tail, storage, network, and other services. So the first design consideration was to separate this compute from storage, right? So you can elastically scale compute and storage separately. And the second was to have data lake, which is our object store, right? And then all your libraries, binaries, or when you run a workload, all the result sets, everything is written back to the object store. So what it means is, big data cluster that you create is essentially ephemeral in nature. If you want to, you can spin up a big data cluster only when it is needed, and once the workload is done, you can clean it off, or you can just stop or kill the cluster. There are no dependencies built within the cluster, right? So that is a modern microservices based architecture we followed. So last year we released Big Data Cloud. As I mentioned, this is the cloud native modern big data 2.0 platform in the cloud, and you can just bring in the data. Do not worry about the complex Hadoop ecosystem and how it is built or configured. We will take care of all of that lifecycle for you. I also want to touch base on one more cloud service along with Big Data Cloud, which is Oracle Event Hub Cloud Service. So essentially it is a Apache Kafka offered as a managed cloud service, because for all the streaming requirements, Event Hub Cloud Service is the platform or the message broker for our Big Data Cloud ecosystem. Now let me give you a conceptual overview of how the data lake services stack looks in Oracle Cloud. Now on the left hand side, you can see all the data sources are listed. It could be coming from various different styles of data sources. And then once the data lands, You may want to do some kind of data integration, data quality, and there are a bunch of services that we have to take care of that. And then finally, you want to securely store and manage your data. And that's where the data lake services come into picture. Now, if you look at the infrastructure layer, we have built a second generation best-in-class cloud infrastructure for all your compute, storage, network, and identity needs. And then there are storage engines that we support. We have our own Apache Hadoop distribution, which is an open source. We have NoSQLs. We also offer open source NoSQL like Cassandra as a service. And we have built a data catalog on top of it for a common catalog for all your data needs. You have various styles of query engines supported. So Elasticsearch is something that we are quickly going to be releasing. And then there is a database integration. So what it means is if you already have a lot of data or a data source systems on your premises or in the cloud that are relational in nature, so we have built connectors for you to easily move data between Hadoop system and the relational source system. That's very securely and efficiently you can move data. And there is advanced analytics capabilities that we have added on top of it for machine learning. We have Oracle R for advanced analytics Hadoop. And of course, if you want to use open source Spark ML, it is supported as well. So this data lake services on top of which you can do analytics using Oracle Analytics Cloud Service. And you have consumers on the right-hand side. Okay, so let me start giving you some feel of how do you interact with the Oracle Big Data Cloud. Essentially, just to interact with Oracle Platform as a Service or Oracle Cloud in general, there are three different ways that you can come and interact with Oracle Cloud. One is the Platform as a Service UI. And then if you want to programmatically approach it, you can use REST APIs. And then for developers, there's also a command line interface available. Now, what all things you can do, how do you interact with the big data cluster or Oracle Cloud Services? You can do various things. You can access REST APIs and do what you call the lifecycle management using REST APIs or UI, like provision, start, stop, scale in, scale out, and if you want to patch, you can patch it. There are other configuration options, looking at logs, downloading, etc. So, and for big data specifically, we have also built a UI experience for cluster console, what we call a big data cluster console. So what you can do here is you can do a job submission. There are variety of notebooks that we are supported. There are configurations you can do. There is the service status. What are the components that are running? What status that they are on? And then you can also do a key management or what we call a credential management in advanced settings here. So the open source that we ship as part of Big Data Cloud is Apache's Hadoop open source, which is again actually forked from Hortonworks 2.4. So what it means is underneath we use Ambari for orchestrating all our provisioning and big data configurations, right? So we also allow users to access Ambari through UI. There's a specific port that you need to open, but we do allow you can access Ambari and do advanced configurations if you wanted to. Now the execution engines that we support, the one thing I would like to highlight is that the strategy from Oracle is that we are investing heavily on the Spark based ecosystem. But at the same time, we also understand that a lot of customers want to move from on-premises to cloud, and they are looking for support for existing legacy execution engines, like we support MapReduce, Hive, HBase, and there's a new distributed cache called as Alluxio. Elasticsearch is something that is coming very shortly, and we also continue to look at other execution engines that are gaining momentum in the market. And as and when we see a lot of demand from our customers for additional execution engines like Flink and NiFi, we will consider them supporting as well. So for the data scientists and for the developers that want to do analytics within the big data console or the big data cluster, we support Zipline notebooks as an out-of-the-box analytics tool. You can easily import and export nodes. You can very easily build explorative analytics. And there are standard variety of interpreters that we support, Spark, R, or Java, JDBC, shell scripts, etc. Now, so if you look at, if you have a cloud experience, so let's say you go to Amazon or Microsoft and say you want to spin up a big data cluster, the first question that you will be presented with is that what components that you want to provision, right? So there are 10 to 12 components will be listed. You have to pick and choose what you want to provision. And in big data world, there are always new components that are coming every 3 months. That means you need to know the technology and you need to know what you want to do with those components. So that's the complex thing to keep up with. So here we are making it more easier for our customers. So what we want to do is we define what we call profiles in big data cluster. So you just tell us what type of workloads that you have, and we will take care of spinning the cluster with the appropriate components for you. And you can always go, once the provisioning is done, you can go and change and make configuration changes. And so today we have a basic full and edge-based profiles. And based on the workloads, you can use them. For example, and there are more that are coming that are on the roadmap, right? So for example, in the next month or two, we will release something called as a snap profile, where we have a new technology that is distributed cube that you can build OLAP for OLAP style querying on top of Hadoop, which is like 100 to 200 times performance acceleration. Now elasticity, as I mentioned earlier, you can independently scale compute and storage, and then you can also of course do a start and stop through UI, REST APIs or anything. We are also building auto scaling. So what it means is you can define a policy, and in that policy you can say, if my CPU utilization goes below or above 70%, spin up an additional node. Or you can say, if my memory utilization drops below, let's say 40%, delete a node. So that way you can balance your resources and better manage your cloud economics. Now security, and today we have a Oracle Identity Cloud Service integration available. That means all your identity is externalized and integrated with Identity Cloud Service for all our platform services. And in the coming releases, we are also going to be supporting Kerberos for security within the cluster, and Apache Ranger for low-level, row-level security configuration management. Cluster customization is an important feature because a lot of customers want every big data cluster that you provision in a specific configured way, right? So which may not be the same as the default configuration that Oracle Big Data Cloud provides. So what you can do is you can build a small script, and what we call it as a bootstrap script, and load it on the object store. So what we do is, once the provisioning is done for Big Data Cloud, we run that script, and that script can customize the entire big data cluster the way the customer wants it, and that can be your gold standard. And also the cluster customization also important for the features like if you want to bring in any third-party open source that we do not support out of the box, you can bring those kind of tools and third-party open source softwares through cluster customization or a bootstrap script capability. Initially I mentioned from architecturally we have object store as the data lake, and then we have a big data cluster, right? So a lot of customers ask this question, so my big data workloads are latency sensitive or they're throughput sensitive. If I have to make a round trip to object store all the time, then that is the big challenge for us. So to counter that, what we have, the new technology we have called as Alluxio, which is a big data file system. It's a distributed intelligent cache. What it does is, the application doesn't really need to know about this cache at all. So the way you access HDFS today, let's say as a developer you write HDFS : / the object. Same way you have to write your application, but instead of HDFS you just say BDFS. So this cache transparently makes sure that the object is available in the cache. If it is not available, it will keep an index tracking of where the object is stored, either on tiered storage on the HDFS or on the object store. So this helps essentially countering these performance requirements. So you can choose an appropriate size of BDFS based on the workload needs, and only the first trip to object store is expensive in terms of latency, but the second trip onwards, everything is in memory. That's how we accelerate the performance of all your workloads. And there are various storage options available. We continue to support HDFS, even though we are of the opinion that you should always use object store as the data lake, but we continue to support HDFS because, again, as I said, a lot of customers want to move from on-premises to cloud and still continue to want to have support for HDFS. And then we have tiered storage through big data file system. Object store, we have both standard and archival. And block store, if you want to have a block storage that is ephemeral or long-lived, both options are available. Now we release the software update every month. It's a monthly cadence. So there are new features, there are bug fixes, and maintenance releases are included. And customer can some of the services options that the customers can choose to update them. Or if you are going for a completely managed option like Event Hub Cloud Service managed option, then you don't have to worry about this. We will take care of updating and upgrading as part of the managed offering. Now let's look at some of the key capabilities. Now one of the challenges that we hear from the customers is that big data projects largely fail because the technology is very complex to manage and learn and to find the skill set. There are various other reasons. So we simplify it by categorizing big data into three important investment areas. Right? So one is integrate, manage, and analyze. So data integration is a big part of our portfolio. There are a bunch of services available. In this session, I will only stick to Event Hub Cloud Service. And then if you want to store the data in secure and manage it securely and reliably, we use data lake services, which is Big Data Cloud. So let's cover those areas. On the integrate, right? So we have Event Hub Cloud Service as one of the key pieces of data integration. It's Apache Kafka as a managed service. So some of the key capabilities that if you want to persist the data, the data can always land into Apache Kafka. And we have connectors written already, and also Kafka supports these stream libraries. So essentially what it means is you do not have to write any additional code to do this data persistence or data transform. It can be out of the box with other connectors that we have built. Right? So it also supports both the stream and batch styles of workloads. Right? So whether it could be streams like clickstream log, IoT sensors, and you can use the connectors that we have built to load data from database, or you can use JDBC connections. And one of the key capabilities is that it's completely integrated with all other Oracle Cloud Stack, whether it's infrastructure or it is other platform services. So you can use REST APIs. We also support a schema registry if you want to define a frame for or define a schema for your incoming data or outgoing data. You can do that. You can also version your schema. That schema's registry is supported. And it is integrated with the data catalog. So the differentiation, because most of the cloud vendors offer Apache Kafka as a cloud service. Now, but if you look at the differentiators, there are very significant things that we have done as an innovation. One is Kafka is deployed on the second generation best-in-class infrastructure service in Oracle. Right? So it's a low latency, high throughput infrastructure that we have that you can scale from single node to thousands of nodes and across availability domains. And then we support native and REST-based APIs. And then finally, the important aspect of Oracle Cloud is that there is a choice of deployment. What it means is Oracle customers can choose if they want to deploy their workloads in Oracle public cloud or data center, Oracle data center, or they can choose to deploy on their own data center with the same APIs, same subscription price, everything remains the same. It's just that you will be running cloud on your data center. Right? So I think today we are the only vendor to offer this on-premises deployment. Now let's look at some of the key capabilities of Big Data Cloud. So obviously there are varieties of storage options that we offer. Now it is not only about HBase, Elasticsearch, and other engines, but there are these object store as a data lake, and the tooling around it really helps you to store and manage your heterogeneous data types. And then you can also query with different profiles, as I said, workload specific profiles, whether you want to be doing a data warehouse or you want to do analytical workloads, all that is supported. SQL endpoints, you can bring in the third-party tools to query the data. And then also the processing, right? So as I said, let me stress again, so we are heavily investing in Spark-based ecosystem. But at the same time, if you are doing Kafka or any streaming requirement, the Kafka is the go forward platform or a message broker for streaming requirements. And then as a cloud vendor, we have a very specific enterprise level grade SLAs as requirements. Now let me run you through some of the differentiators in Big Data Cloud. And performance has been always one of the differentiators across all our portfolios. And here it's the same. So we continue to enhance and develop better performance for Hadoop ecosystem, and that's one of the pain points for most of our customers. So I already talked about Alluxio, which is a distributed cache. We are also introducing what we call at scale OLAP style querying for analytical workloads that sits on top of the big data cloud. That's called a SNAP. So that's also we are introducing in a month or two. So essentially it's a better performance with also additional advanced analytic capabilities with machine learning, like Oracle R for advanced analytics Hadoop, and other tooling that we provide around it. And then you also have a choice of deployment. That's important. If you want to deploy big data cloud in Oracle data centers, you can do that, or you can deploy on your premises big data cloud. And the third one is the catalog, right? So we have a single common catalog for all our platform services, and it is important for all your data governance or data security standpoint. Right? So you may want to do data lineage. Hey, where this data came from? What are the transformation it went through? Where it landed? All those analysis that you can do through the data catalog. And let me also give you some options that you have to bring in data from on-premises or some other application systems to Oracle Cloud. One is you can bring in data to object store. There are a bunch of options available for you. Some of them are like you can bring it through REST APIs. There is a storage cloud appliance available. You can run it on your data center, and the applications can write to NFS mount point, and that appliance can push data to Oracle Cloud. And there are tooling available with FTM, which is a file transfer manager. You can use APIs. And also there is a physical bulk transfer available where we will move a ZFS appliance to your data center. You upload your data to ZFS appliance, and then we will FedEx that to Oracle data center to unload, and there's a standard process to do that. And obviously you can also use a dedicated pipe using, let's say, Equinix for your fast connect options. And also if you have, as I mentioned earlier, if you have an ecosystem where you already have on-premises data sources and you want to move that data to and from Hadoop ecosystem, we have connectors already built. So we already have those connectors for on-premises systems as well. And the same connector, same command line, we have ported to the cloud environment as well. So, right, so you can use the same skill sets and the same tooling across both on-premises and for cloud. So now Oracle Loader for Hadoop is a connector where if you want to load data in a fast, secure way, bulk data transfer from Oracle source system to Hadoop, you can use this connector. And similarly, if you want to move data from Hadoop system to Oracle data sources, you can use Oracle copy to Hadoop connector. So we continue to add more connectors for better and faster data movement, and these two are already available for you to use. And Event Hub is always a popular data ingest mechanism for many use cases, right? So you can always land a data into Oracle Event Hub Cloud Service. From there you can either persist the data into cloud storage or move it to other source systems like relational databases or NoSQL databases. We also have connectors available from moving from Event Hub to database or to object store. Now some of the advanced analytics machine learning capabilities in Oracle Big Data Cloud, by out of the box we support these pre-installed open source machine learning libraries, and you can also bring in the third-party open source tools through Bootstrap capability. So we recommend you use Oracle's R for Advanced Analytics Hadoop. Now that's because we have a richer set of functionality compared to the open source that is available in the market, and you can refer a lot of additional content for richer functionality and faster performance, etc. And customers can always choose to use the open source that is available. Now Graph Analytics is one tool. Again, this we provide support out of the box. We will be announcing in a month or so. This is again much better tool, value-added tool compared to the open source like Neo4j or DataStax Titan. You can see a lot of content available on oracle.com where these tools are provide you a much faster performance and richer functionality. Spatial analytics is another additional tool that another additional technology that we support with Big Data Cloud. You can use that as well. And these are some of the machine learning algorithms that we support as part of Oracle R and advanced analytics in Oracle systems. And we continue to enhance and add additional support for new algorithms, optimize the existing functionality, etc. So you keep a track on advanced analytics for Hadoop. So just to summarize the big data differentiators, performance is one big thing, right? So because of the infrastructure and the optimizations that we have done. Machine learning capabilities and advanced analytics is a huge area where we have invested and done a lot of innovation. A data catalog that differentiates from other vendors because we have a single data catalog for all the platform services and all your data platform needs. And then finally, choice of deployment. You can deploy big data on your premises as an Oracle cloud, or you can deploy a big data on Oracle data centers as a public cloud. Now the key use cases. So enterprise analytics is a very popular use case where a lot of enterprises have siloed data floating around in departments or LOBs. They are trying to create a single source of truth and bring in some kind of Hadoop flavor to it, or maybe a data warehouse, offload ETL, right? So that's one popular use case that we see, and there are a bunch of other services obviously you can see that you can use with Big Data Cloud here in this use case. Data lake analytics is growing and the popular use case where customers specifically want to build a data lake and then do a schema on read. The data lake use case is popular where you can do a data integration, data management, and analytics using Oracle Cloud Services. And there are customers that are building smart applications for their users or customers to proactively create self-service analytics from big data. So again, Big Data Cloud, Event Hub Cloud are these important pieces of this Lambda architecture. And again, you can use other services for data integration, data management, and data analysis. Now, so just to give you a high-level overview where we are investing is, this is the modern data architecture that we are investing continuously. We continue to evolve the data science ecosystem on top that sits on top of streaming and data lake. And we continue to support various other technologies that are evolving, whether it's SQL or NoSQL. Today we already have Cassandra as a service or Oracle Data Hub cloud service, and then we are building AI platform cloud services as well. Now this is an AI and machine learning PaaS capabilities which is on the roadmap, so you will hear more about in a month or two. Now I just want to give you a quick demo how you can build a big data analytics applications using Oracle Cloud. So here I'm going to be showing you a demo on customer segmentation analysis. So let me do a role play here. So let's say I am a data scientist in a retail company called as My Walmart. So now the marketing department has come to me and saying that they want to run a targeted campaign for customers in California and Texas who are owning a house, so that they can go and run a targeted campaign for these customers. Right? So I want to build this customer segmentation profile for my company. So for that I just want to do analysis for and we use 3 different source systems. Right? One is all my customers' records are stored in my enterprise data warehouse, and then these customers are transacting all across the United States. That means I have stored transaction data in another system, and then these customers are also tweeting about the services and the experiences that they have had. Right? So I want to combine all these 3 source systems and build a customer profile, and then there we can identify some social pattern and sales pattern and also do a specific targeted campaigns. Now how would my demo look like? So that the demo architecture would look like this. Now usually the data warehouse and the store transactions are 2 separate systems in an enterprise, and if you look at the left hand side, the Twitter feeds or the social media feeds that are coming in, and there is a Kafka topic where all these social media feeds or the Twitter feeds land. Now there is a Spark job that is waiting for messages to come in so that it can read those messages and put those messages in a Big Data Cloud HDFS. So from the HDFS, what I'm going to do is I'm going to create a Hive table. So what it means, now I got hold of one source system, which is the social media feeds. Similarly, what I'm going to do is I'm going to pull the source customer profiles from data warehouse and then store transactions. That means all the 3 sources are in my Hive table that I can do analytics using Oracle OAC. So that's the demo architecture. So how does it look really on a cloud from the topology standpoint? So one is what I'm using here is we need a storage cloud, which is a backup container in this case, and then I need a Event Hub Cloud, which is a Kafka broker and a topic. Instead of using two different data source systems, I'm going to be using just one database cloud service, and then the Big Data Cloud and OAC, Oracle Analytics Cloud. Now let me quickly go through how you can easily build these real-time applications. I'm going to log into Oracle Cloud using my identity domain, username and password. Now I get to my landing page on the cloud services. First thing I need to build is a cloud stack. What it means is I have around 7 cloud services that I need to provision, and I really don't have to do each one by one, providing 15, 20 configuration details. So what I can easily do is, using cloud stack, I can create a template using YAML scripting and simply import that template in my cloud. Now I just imported the template, and you can see that when I click on the template, I can see I have already built these 7 cloud services topology in my template file. So you can see this template file is simply a YAML script. You can build dependencies within these cloud services. You can say these cloud services need to be provisioned in a particular order. There's a specific dependency and all that. And this also helps you quickly and easily develop applications and do a continuous integration and continuous development type environments. I'm going to provision these cloud services. Now my cloud services are ready. So the next step would be to create a job, Spark job, which is going to be waiting for incoming Twitter feeds. How do I do that? I simply go to Big Data Console in my Big Data cluster. And now I have a Big Data cluster console here. I'm going to go to Jobs and create a new job. So I'm going to call it as a social media job. And then I'm going to provide the specific job information on this page. Now you can see that I am telling this job that in the arguments I'm specifying there is a Kafka broker running, and there is a Kafka topic where the Twitter messages are going to be coming in. And once the messages come in, and consolidate these messages as a output file on my HDFS. Right? So I submit this job. Now this job is going to be waiting for Twitter feeds on the specific Kafka topic. Now what I'll do is, obviously because this is a demo, I need to map my existing demo data with the Twitter feeds. So I am not going to pull the real-time Twitter feeds, but rather simulate a bunch of Twitters that I have in a CSV file. So here I am using a producer script which comes out of the box with the Kafka install. So I'm going to use that script to create messages or populate messages into the topic. Now once I run this command, the messages are already written into the topic, and at the same time the Spark job must have read it and already written back to HDFS as a file. You can see that the social media EHCS file is created on HDFS. Next step, what I'll do is, now I will create a Hive table that points to this HDFS. Right? So Big Data Console, I'm using a Beeline client here, and now I'm going to create an external table. You can see that it is pointing to a temp location where the CSV file is, or the Spark has written the CSV file. Now this is an Oracle Database Cloud. Now I see that there are 2 customer records and point of sales data already available in Database Cloud Service. I want to pull these 2 data sources or tables into my Hive tables. How do I do that? There are multiple ways to do this. One is, as I talked about, you can use big data connectors, and the other is simply use a notebook and use the JDBC connection to connect to your Oracle database. So you can see that in the first 2 lines, you can create a simple JDBC connection, and you can pull tables from Oracle database into your Hive table. It's so very simple to interact between Hadoop ecosystem as well as a relational. So now I go to Big Data Console. Now I see that all those tables are consolidated in one source system, which is Hive tables in this case. So now I have customer records, I have a point of sales data, I have a social media feeds, everything in one place. Now I'm going to go to Oracle Analytics Cloud and launch Analytics Cloud for connecting to Hive tables. So Oracle Analytics Cloud provides you a very intuitive way of using and connecting to a variety of source systems. So in this case, I'm going to connect to a Spark. Once I connect, you can see that I see a default database in my Hive. When I double click, I can see all the tables that are available in my Hive system. Now I am going to select all of them and start my analysis as a data scientist or a business analyst. So now, because I have all the data accessible to me, but I don't need all of the data. So I'm going to create a data flow and only pull a subset of data from my Hive system. How I can do that? So I can simply create a data set using OAC. It's a very UI driven experience. On the left hand side, you can see that there are three sources that I'm using: social media, customer records, and point of sales table. I simply define a filter saying that, okay, if the customer Twitter profile matches with my customer record, which has a Twitter name on it, then only pull those records. Right? And then you can do a bunch of cool stuff like add additional calculations, aggregations, and all that. And then finally, on the point of sales data, what I do is I simply match my customer loyalty ID with the customer record royalty ID that I already have in my warehouse. Right? So that means now I combined all of these three sources, and I'm going to run this data flow against the Hive and pull only this filtered data. Right? So you can simply save this data flow and run it. Right? So now I have subset of data, or the only data that is required for my analysis, and then I can go and create some cool visualizations to get more insights into my customer analysis. Let me open some of the dashboards that I have already created. You can see that in this dashboard, what I have done is this is a high level bird's eye view of all the transactions that have happened in my Walmart store. Now there are total sales of 1 million. You can see the total spend by customers, what is the average transaction value, how many times customers visited. So you can do a variety of analysis that you want. And there's a POS, point of sales volume trending over the year, and you can see that during Christmas, holidays, it peaks. And there's a spend pattern across the United States. You can choose your own analysis. So on this customer binning, what I'm doing is I'm trying to understand the low spending customers versus high spending customers. I have created the buckets, 20 buckets here. You can see that the customers that spend between $75 to $150 are the ones that are creating to the volume of transactions, or the sales volume is higher there. Similarly, the chart you can see on lower left, where customers visits versus transaction volume. The customers that visit between 3 to 4 times are the ones that are contributing more to the transaction volume. On the right hand side, you can see the tonality. So customers that visit twice or thrice are the ones that are contributing to the transactions, and the tweets that the customers that are tweeting the most are in the range of between 2 to 3 tweets per customer. Right? So these are the type of analysis you can do, and you can do additional customer profiling. I already have this data with me. What is their occupation, what is their education, whether they own a house or they rent a house, what is their income profile. Right? So a bunch of analysis that you can do, and you can easily drill down and apply some filter. So let's say $75. Let me apply this filter. Now I can see that some of the this visualization is only for customers that are spending less than $75 per visit. And on the geography side, I can always choose, let's say, let me show data only for California. I can apply that. Now I see that the charts change, and various styles of visual analysis, intuitive analysis I can do now. And let me create one more data flow, because my marketing department wants customer segmentation list, where they want to target those customers who live in California and Texas and who also own a house. Right, so what I'm going to do is, now this time for me the source system is going to be the subset that I already pulled in from the Hive. That means I don't have to do a query from the big data cloud, but I can do it right here in OAC. What I do is I simply create an additional filter which says show me the data for California and Texas only, and where the customer owns the house. Right, so I simply create this data flow and run it. Once I run this data flow, the customer segmentation list is available to me in Oracle Cloud, Oracle Analytics Cloud, and I can download that spreadsheet and share it with my marketing department to run their targeted marketing campaign. Right, so we easily could consolidate 3 different data sources, built analytics on top of it, and worked with analysts. So it's so very easy to do, interact with the Oracle Cloud and get an integrated experience. If you want to try Big Data Cloud, you can go to cloud.oracle.com and Big Data Journey. There is a $300 free credit available for you to try. Thank you for your time to watching this. I hope you found this information useful. For more information, you can go online at cloud.oracle.com. And thank you again for watching.